NASA's recent press conference on November 19, 2025, captured global attention as scientists unveiled new and remarkably detailed images from various space missions tracking Comet 3 I/Atlas, the third known interstellar object ever detected passing through our solar system. The conference began with Associate Administrator Amit Kshatriya addressing the surge of speculation that had been circulating on social media platforms in recent weeks. Many users had been fueling rumors about extraterrestrial life or alien technology, with some posts even suggesting the object's odd trajectory and composition were signs of artificial origin. Kshatriya firmly dismissed these theories, emphasizing that Comet 3 I/Atlas is fully consistent with what astronomers expect from an interstellar comet, and that no data suggests anything beyond natural cosmic phenomena. This reassurance helped redirect public focus back toward the scientific significance of such a rare visitor, as interstellar objects present opportunities to study material formed around completely different stars. NASA had deployed an impressive network of spacecraft, probes, and observatories to image 3 I/Atlas from various vantage points across the solar system. Among these, the Mars Reconnaissance Orbiter managed to capture some of the closest and sharpest visuals. On October 2, 2025, while the comet was still 19 million miles from Mars, the orbiter's powerful instruments photographed its nucleus and the early development of its dust tail. Even from such a great distance, the images demonstrated surprising structural complexity, with faint jets already beginning to emerge. Scientists noted that these early jets suggested the comet contained volatile materials different from most comets originating in our own solar system, which may reflect the chemical conditions of the comet's birth system. This alone offered exciting prospects for comparative studies between planetary systems, allowing researchers to analyze how ordinary or unusual our local cosmic neighborhood truly is. As Comet 3 I/Atlas approached the Sun, numerous talented astrophotographers also contributed to the growing library of visuals. Michael Yeager, Gerald Riemann, and Enrico Prosperi, all well known within global astronomy communities, captured breathtaking photos shortly after the object passed near perihelion on October 29, 2025. Their images, shared publicly through the ICQ Comet Observations Facebook page, quickly gained popularity among both amateur and professional skywatchers. The photos showed dramatic transformations in the comet's appearance caused by intense solar radiation. As 3 I/Atlas swung around the Sun, high-energy particles struck its surface, vaporizing ice and dust in spectacular patterns. Jets erupted in multiple directions, giving the comet a wild, almost explosive look that fascinated researchers. These features demonstrated that despite its alien origin, the comet reacted to solar heating much like long-period comets from our own Oort cloud, which strengthened the case that its behavior aligned with natural astrophysical processes rather than anything artificial. The astrophotographer's images also helped scientists observe how the comet's tail structure changed as it absorbed solar energy. Some frames showed multiple distinct tails, one composed of ionized gases glowing faintly and another of dust streaming outward in a curved path shaped by solar wind and gravitational forces. These dynamic features provided clues about the distribution of materials within the comet's nucleus. Yeager, Riemann, and Prosperi were praised widely for their contributions, as their early images allowed the public to participate in the scientific journey. The clarity of their work helped people appreciate not only the beauty of 3 I/Atlas, but also the fragility of such objects when exposed to the intense heat and radiation of a star. Comet 3 I/Atlas holds special importance as only the third interstellar object ever recorded entering our solar system, following Oumuamua in 2017 and Comet 2 I/Borisov in 2019. Unlike typical comets bound by the Sun's gravity, 3 I/Atlas has a hyperbolic orbit, meaning its speed and trajectory indicate it originated outside our solar system and will eventually escape back into interstellar space. Calculations showed that its closest approach to the Sun occurred at 11:47 Universal Time Coordinated on October 29, 2025, when it passed at a distance of 1. 36 Australian dollars, equal to about 126 million miles. At that moment, scientists closely monitored how the comet's materials reacted to maximum solar heating. Observations suggested that its composition includes exotic ices that sublimate at different temperatures than most comets studied previously, hinting at the unique chemical history of the distant star system it came from. Some researchers speculated that the comet may carry clues about organic molecules formed in conditions unlike those found near our Sun. Despite the intense excitement surrounding its solar flyby, 3I/Atlas is still on its inbound leg relative to Earth. While it has already passed its perihelion, it has not yet made its closest approach to our planet. Its nearest distance to Earth is predicted to occur around December 19, 2025, when it will pass at approximately 1.8 Australian dollars, about 168 million miles away. Although this is relatively close in astronomical terms, it remains much too distant to be seen with the naked eye. Even large binoculars will not be sufficient. Only telescopes will reveal the faint glow of its nucleus and the delicate traces of its dust tail. This limitation has led some astronomers to encourage local observatories and sky watching groups to organize telescope gatherings during the comet's December passage. Such events would provide the public an opportunity to witness a visitor from another star system before it fades into darkness and returns to the cold expanse of interstellar space. The study of Comet 3I/Atlas offers far more than just pretty images. It presents a rare chance to examine the building blocks of planets beyond our Sun. Scientists believe that comets form during the early stages of a solar system's creation, when dust and ice grains stick together and gradually grow into larger bodies. Studying a comet that formed around a distant star might help researchers understand how different planetary systems evolve and whether certain types of volatile materials are common throughout the galaxy. The chemical fingerprints in the comet's tail and nucleus could reveal the kinds of organic molecules present in its birth environment, offering insights into how widespread the ingredients for life might be across the Milky Way. While the public imagination often leaps to extraterrestrial life whenever something interstellar appears, the true scientific value lies in understanding cosmic processes on a universal scale. NASA's coordinated observational campaign included not only spacecraft near Mars and Earth, but also powerful space telescopes such as Hubble, the James Webb Space Telescope, and several ground-based observatories scattered across the globe. Each instrument contributed different types of data. Webb's infrared imaging revealed temperature gradients across the comet's surface, while Hubble provided high-resolution visible light images showing fine details in the tail. Ground-based observatories monitored rapid changes in the jets and outflow patterns. When combined, all these datasets painted a vivid picture of a comet undergoing dramatic physical change as it interacted with our Sun's energy. Scientists will continue analyzing these results for years to come, using them to refine models of how icy interstellar travelers behave under varying environmental conditions. As 3I/Atlas leaves the inner solar system, its brightness will gradually fade, and most telescopes will no longer be able to track it. Ultimately, it will slip back into deep space, continuing on a path shaped long ago by gravitational encounters in its original star system. Its journey through our solar system, although brief on a cosmic scale, has provided invaluable information to astronomers. Every interstellar object adds a new piece to the puzzle of how stars and planetary systems form, evolve, and distribute their materials across the galaxy. Comet 3I/Atlas serves as a reminder that our solar system is not isolated or unique. It is part of a vast interconnected galaxy where objects can wander across immense distances, carrying with them stories frozen in ice for billions of years. Even though the comet will never be a spectacle visible to the naked eye, its scientific significance makes it one of the most intriguing astronomical events of the decade. For anyone with access to a telescope, December offers a rare chance to catch a glimpse of an object that has traveled unimaginable distances to pass briefly near Earth before disappearing forever into the cosmic void. The excitement sparked by scientists, astrophotographers, and enthusiasts alike shows just how deeply humanity remains connected to the mysteries of the universe. And as NASA continues sharing its latest observations, the journey of 3I/Atlas will stand as a moment when we were reminded that even in a technologically advanced age, the cosmos still holds wonders that inspire awe, curiosity, and exploration.